Good day, everyone. In our previous class, we discussed on data modeling, where we've been able to define the modeling itself. The data model, we look at the types of model. Thus, we look at the conceptual data modeling, the logical data modeling, and the physical data modeling. And in that process, we've been able also to look at the advantages, disadvantages, and then the characteristics of all these types of data modeling in database management system. I remain Mr. Mahmoud Ahmad Bamanga, and today in this session, we are going to look at relational model, where we are going to concentrate on relational algebra in database management system. Relational algebra is the fundamental concept of database management systems that provide us with the ability or the structural approach in order to what? To query information or query data that we have stored in the database. So it also allows to what? To navigate in between these relational tables because our database have been created in form of tables so that we can be able to pull out those data or information, making it easy to understand and manipulate with our queries or manipulate queries easily in our database management system. In doing that, also we are not going to forget uh, we said our class today is centered on relational algebra. And this relational algebra is the foundation for our database design. Because if your database cannot be able to what? To respond to a certain queries that is what? Developed by the database designer, it means that database will be rendered useless. So this relational algebra is the formal query or formal query language used in order to manipulate and then query data that is being stored in this relational database, which is in form of what? In form of tables and what have you. So it provides us with a set of operations that can be what? That can be combined in order to express complex queries in a concise and precise manner. So we are going to look at these key operational activities that are done in what? In relational algebra. One, we have what we call selection operation. We have what? Selection operation is the key in relational algebra, which is represented by a sigma. It's represented by a sigma. So in this selection criteria or selection in relational algebra, what it does is that it enables you to select what? A tuples in a relational database. That's what this enables you to do. So we have its syntax, which is denoted by the syntax of this is denoted by what? The syntax of selection criteria is equals to our sigma, then we have condition, then we have relation. Are we together? So this is going to be, for instance, if a table is given student, it's going to be what? Our sigma underscore probably we can say age that's less than 18. Which relation are you cutting this to? From what? Students. So this is the table name. This is the conditions you want to select. So it means you want to select only student with the age of less than what? 18 or with the age of greater than 14. That's what this selection criteria does. So we also have what we call projection. In our projection, a relation onto a subject of our attribute, that's what it does. So it's going to select the relation or the tuples within a specific given range. And the syntax of this, sorry, the projection criteria or projection operation is what? Denoted by a pi. Whenever you see pi in relational algebra, it means projection operations. And then the syntax for these projection operations is denoted by what? By pi. After you have your syntax, you have pi underscore select attribute, select attribute into what? Into a relation. So that's what this projection does. So we also have what we call union key operation. In our union key operation is the normal union that we are having in what? In a set operation, that's mathematical set operations, right? So this what it does, it what combines the relations, it combines the attribute within the given two relations. This the syntax of this is what? Syntax of this union is going to be when you are having a relation one, you are going to have a union with a relation two. That's all. And then we also have what we call intersection operation. In intersection operation, is going to give you what is common in one relation to another, just like our set operation, intersection operation, which is denoted by intersection symbol, and the syntax of this is going to give you relation one intersection relation two. Are we together? So that's what this intersection operation does. So we also have a set operation, a set difference, sorry, a set difference operation, set difference operation, this denoted by minus. So what this gives you is that it's going to give you what in the relation A and not in relation B. That's what our set operation does. And the syntax is relation one minus relation two. That's the syntax of our what? Of our set difference operation. So we also have what we call Cetacean product. The system is Cetacean product. In Ceta, which is denoted by X, in Cetacean product, what it does, it multiplies the attribute or the tuples in one relation to the tuple of another relations in another table. The syntax of Cetacean product is a relation or the tuple in relation 1 multiplied by the tuple in relation 2. So that's what we have in Cetacean product. So, and you see this 5 or 6 key operation in relational algebra is what we are going to use today and see how we can be able to query data from our database. So we have for the first operation in this relational algebra, which is called selection, which is what? Selection uh, of a tuples in a what? In a given relations. If a tuple is given as relation R is equals to, and we have a record with this A, B, C, and D. So all these denoted like this, and we have alpha, beta, so that we also have alpha here, we have beta, we have beta, then we have 1, 5, we have 12, and we have 23. The other one we have 7, 7, 3, and 10. So if this is given as the relation R, and the question says you should what? Look at the relation, or you use your what? Selection operation of A equals to B, and then we let's use this place. Let's of what? A is equals to B, and then B and D is greater than 5. Or your selection operation of A equals to B, and that's using the double ampersand, D greater than 5. So this is what they are requested of you to do. So you are going to you are coming here now. At the first tuple you will see which one, where is A is equals to B. So here we have A equals to B. Are we together? A is not equals to B, so definitely this is going. This A is equals to B. This A is equals to B, right? So, but the issue again, they want what? You are selecting only that. We are taking only this. So we are going to return with A, B, C, D, where we have alpha, beta, beta, and we have 1, we have 12, we have 23, we have 1, sorry, we have alpha, we have beta, beta, 1, 12, and 23. Whereas here we have 7, we have 3, and we have 10. So in this selection criteria, we are done with A is equals to B. And again, here we are looking for another condition which states what? D should be greater than 5. So here we are going to return where does this value of 7 greater than 5? The answer is yes. Does this greater than 5? The answer is wrong. This is greater than 5, it will return true. So we are now getting out of with this and return finally. We are going to return with what? A, B, B, C, D. But remember, here we are only concerned with A, B, and D. Therefore, we are returning A, C, and then D. Where our A, we have alpha, we have beta, and here we have 1, we have 23, and here we have 7, we have 10. So this is the what? This is our as the result of our selection operation. But in the case where they ask you to what? Select where A is equals to B and then D is less than 5. So in this selection criterion, you are going to what? You are going to be returned with what? You are going to do the same comparative operation again. Here, let's get out with this and return our what? Our beta, beta, we have 5, we have 12, and then we have 3. So here now, you are going to compare this, those 7 less than 5, the answer is false. Does this less than 5, the answer is true. Does this 10 less than 5, the answer is wrong. So here you are going to return with A, B, and D as you are what? You are returning only this. You are going out with this, and you have your beta, beta, 12. So we are not taking 12, then we have 3. So this is the result of these operations where D is less than 5. So this is how you go about what? Assuming here we have what we call our A, B, C as the relation, and we have alpha, alpha, beta, beta. So we have 10, 20, we have 30, we have 40 on what? On B, and we have 1, 1, 1, and 2. So If they said you should select A and C, select A and C, then you have your projection criteria. You have your projection as what? This is the projection as what? As your pi given at AC, then you have your R. So this is the what? Projection criteria in what? AC of R given ABC. So first of all, if you are dealing with this, you are going to select these tuples only, A and C. You are not selecting B. Are we together? So here you are coming with A, C. You have your alpha, alpha, beta, beta. You have your 1, 1, 1, and 2. So the next one they are saying now, you are taking a projection of what? Projection of A and C. So what you're going to look at here, what is it that are in what? A and B. So what you are going to look at here, we know we have alpha here, we have alpha here, isn't it? So this alpha, they are common here. So you are going to take out one alpha since what? What is in A and C, they are the same. So you are going to return with A, C as your what? Alpha 1. So you are taking out this and then use this, or you take out this and use this, because these relations they are of similar, or they are of similar tuples or records, right? But looking at this beta, we know this is beta, this is beta, but the value in C or in relation C, they are not of the same value. So you are returning beta here as 1 and then the beta here as 2. So assuming now this value is to say is 3, so you are going to return, your answer will stop here. So definitely this is the what? This is the record that you are going to be provided after you have given out the selection criteria in what? In database management system. So this is how we are going to use our projection in order to what? Pull out data from our database management system. So we have what we call joining two relational or joining two relations using Cetacean product. Using Cetacean product, you are going to use this. You remember our Cetacean product state that you are going to what? Multiply each column or a row of a second relation with the what? Instance in the first relations. So if to say your relations is given as relation of what? R and S, where where your R is equals to, we have A and B, and these are denoted by alpha, beta, 1 and 2. So this is what? This is for R, right? So for the A's, we are going to have C, D, and E. This is what we are having. A's now. Are we together? So we have alpha, beta, beta, and gamma. Alpha, beta, beta, and then gamma. So here on D we have 10, 10, we have 20, we have another 10. Here we have A and B, A and B, B. So you have your what? They ask you to find L and what is a relation of use Cetacean product to find out the relation between R and what is. So what you are going to do here, we know. Definitely they said, or the syntax said that each row you pick here must what? Must multiply through this whole table. Are we together? So what we are going to do now is we are going to have formulate this A, B, C, D, and E. So that we are going to have A, B, C, D, and then our E. Are we together? So we are having this like this. So we have in our A, we have what? Alpha. In our beta, we have what? 1. So you are multiplied through this, mean that you are going to pick through what is here. So you are having what? Alpha, 10, and E. Are we together? So you are going to do the same thing here. You are going to have alpha, 1, the same thing here. And then you pick what is inside this place as B, beta, sorry, 10, A. The same thing here, alpha, the third one is beta 20 B. Are you together? So the third one is alpha, fourth one, sorry, alpha 1 dent. You have your gamma, you have your 10, and you have your B. You are done with this. Now this is done. So you are going to return to this. You have your beta 2 dent. You have your alpha 10 A. Are you together? So you have your beta again 2 dent. Beta 10 A. The same thing, beta 2, you have your beta, you have your 20, you have B. The same thing for the fourth one is beta 2, you return the same gamma, you have your 10 and B. So this is what you're going to return if you're using Cartesian product to multiply the two tables here. So assuming if and only if we have another one here called what? Called a gamma again 3. So it means still you are going to use for gamma and then multiply through this table in what? In the subsequent relation. So this is how you are going to use what? Cartesian product to come up with this query. I believe this is also well understood. So we have what we call union of two relations. This is where you are going to use your set operation knowledge you acquired in MTH 211 or 122 to solve this very particular problem. Where a relation R and S is given as R as what? R is given as AB. You have this operation as alpha, alpha, beta, and we have 1, 2, and 1. So if this operation is given as R, and you have your S operation or S relation is given as AB, you have your alpha, beta, you have your 2 and 3. So this is the second operation. So you are going to use the same thing like what? Set operation. We know it. So this we are going to use our set operation in solving this very particular value. So the only thing is just to sum up everything and come up with what? With one single operation of R union S is going to be like you have your A, you have your B. So what is in A and still in B? So we still have our alpha here, we have 1, right? We have our alpha, we have 2. So this and this cannot be repeated again. Once you take 1, you are done. So the second one we have beta 1, we have beta 3. And that's all. That's all we need in this operation. Are we together? So assuming now this alpha is 5, so we might also decide to have alpha 5, and then we have beta 1, and then beta 3. Are we together here? So, but since what? This is 2, we know this and this, they are of the same tuples. So we are going to have them just like the way we had them before as our beta 1, then beta 3. So we are done with this set of operation. For what? For union operation. So in this case again, if we are going to have an intersection operation of this same value, if we are going to have intersection operation of R intersection what is of this same thing here. So we are going to look at what are in this and still in this. This is the what intersection operation. We know alpha 1 is not here. Alpha 2 are here and they are here. So we have our AB as alpha 2. And that's all because this is not included here. So you are going to look at the what? The common instance in this very set of operation. That's what we are going to look at here in what? In alpha, in what? In intersection set of layer of relational algebra. So we said we are going to look at set difference. I think this is the last one we have in what? In relational algebra. So in your set difference, what is going to provide you with? You are going to look at what is here and not here. So if they say you look at what the relational difference of A's and what and A's, it's just like you are going to subtract A's from what? From what? From B. A's from what? From R. That's what they are expected of you to what? To do. So here, you know definitely you are going to look at what is inside R and not inside this. So you are going to return with A, B, and you have this operation R and this, they are in A, they are in R. You have your alpha 1 and are they here? No. This one they are here and they are here, so we are not going to deal with them. And this is here but not here, so we have beta 1. So we are not talking about what? About the third one here. But if they said S minus R, so you are going to look at what is inside this and not inside this. So definitely you are going to return with what? Your bet A, B, where you have your beta equals to 3. This is what you are going to return with in this scenario. I believe this is well familiar in our today's session. So this is how you go about what? About working with your relational algebra in database management system.